Something that all of the various underground mining techniques have in common, bord and pillar, stoping, caving, longwall mining, is that they take place in underground environments where fresh air does not naturally occur. Not surprisingly, ventilation is of critical importance to the occupational health and safety of underground workers. A continuous supply of good quality air is absolutely essential to allow personnel to breathe, to dilute toxic and flammable gases, to dilute or carry away dust and aerosols, and to provide cooling for personnel and machinery. In this topic, we will look at the various issues that arise with regard to people working underground and the principles behind mine ventilation systems. Ventilation is the control of air movement, its amount, its quality, and its direction, to maintain a safe and healthy environment in which miners can work. A lack of proper ventilation can cause lower worker efficiency, decreased productivity, increased accident rates, and absenteeism. The hazards which are controlled by proper ventilation in underground mines include low oxygen content, toxic gases, flammable gases, fumes, humidity, temperature, airborne dust, and the products of combustion. We are going to look at some of these hazards in detail. A mine ventilation system must provide air in sufficient quantity and flow to all places where people travel and work in safe oxygen concentrations between 19.5% and 23.5% by volume. Oxygen in mines can be diluted by contaminants such as dust, aerosols, diesel fumes, blasting fumes, as well as gases released from the rock strata, consumed due to oxidation of reactive minerals such as sulfides, and consumed by combustion engines. Gaseous contaminants in mines may be toxic, asphyxiatic, or flammable. In areas where toxic or asphyxiatic gases are present, very limited or zero exposure must be maintained. Where flammable gases occur, concentrations must be prevented from entering the explosive range. Gaseous contaminants may include methane and other hydrocarbons, carbon dioxide, carbon monoxide, oxides of nitrogen, sulfur dioxide, hydrogen sulfide, hydrogen, ammonia, and radon, and any of these can displace oxygen, leading to asphyxiation. Methane and other hydrocarbons have a special significance in underground coal mining because these gases are flammable and potentially explosive. We'll give more consideration to explosive gases in the next topic. In addition to gaseous contaminants, there are airborne particles which can include inspirable dust, which are particles large enough to see, and respirable dust, which are particles too small to see. If dust concentrations are too great to be carried away with the moving air, then special filters called scrubbers can be employed to remove the dust. The risks associated with dust will be given further consideration in the following topic. To consider the basic principles of ventilation in an underground mine, let's consider some room and pillar workings. In general, a ventilation system seeks to direct air in the mine through an entry shaft or tunnel called the intake side and direct it back to the surface via a different path called the return side. Air flows in response to differences in pressure, which for underground mines are generated by primary fans situated at the surface. Fans can either push air in at the intake side or suck air out at the return side. Each approach has its own advantages and disadvantages. As a mine develops, the extent of open underground space increases. However, only current work areas need to be well ventilated, and abandoned areas reduce the efficiency of the system. To control where the air goes and how much gets there, disused areas and shortcuts are sealed off by stoppings. These are walls made of masonry, concrete blocks, timber, steel, etc., erected across openings to direct or channel flow. Even with stoppings to direct flow, airflows may not be balanced where there are multiple airways. Regulators, simple fabric sheets blocking the airways, are used to reduce the airflow to a desired value in any given airway. Where satisfactory pressure or flow cannot be achieved using stoppings and regulators, booster or auxiliary fans may be employed. As stoppings are barriers to access as well as to airflow, steel man doors or airlocks are mounted in stoppings between intake and return airways. Factors which determine the total primary volume capacity and pressure requirements for a mine include the extent and depth of the mine, the complexity of the mine layout, and the stopping and extraction systems, together with the size of the development openings and the equipment used. To maintain an adequate ventilation system throughout the life of a mine, careful advanced planning is necessary, as the size and shape of a mine evolves continuously. A well-designed ventilation system should be effective, flexible, and economical.